No, I don't want to record. Not yet.
That's up. Let's turn that down. Okay, anybody have any questions on homework stuff before we get back into where we left off? I'm a little concerned. There really should be questions. There were some people asking questions earlier, but not a ton. When is our next quiz, by the way?
Wednesday.
Thursday?
Yeah, so I'm going to keep it on Wednesday, depending on what the pace is. What happened? Did somebody else have a different suggestion?
Oh, I thought it was Thursday. I remembered it was soon, but I was not right.
I see. You're just being hopeful. I'll keep it on Wednesday. It depends on if we finish chapter 4 or not, but whatever we get through in time, that'll be what's on the quiz, and we'll talk about it as we get closer to it. Just keep that in mind. A few more people just logged in. Anybody have any questions before I get into stuff? 42 and 3-3. I don't know. Let's find out. Get over there. Shabba. 42. Oh, okay, sure. You missed it earlier. I was talking about this, so this will be good. I can get this. Oh, shoot. I'm going to have to do this every time, aren't I? All right. Hold on, everybody. I don't know. What do you guys see now? Oh, shit. Let me try this again. Oh, shit. Is it going to do it to me again? This seems exciting, Jeff. What good is your new technology? You have to do this every time. There we go. Okay. You see 42 here, right? Please, thank God. All right. So who asked me this question? Can you help me out? What have you got so far? Oh, somebody was chatted to me. I don't know if you have the ability to speak in Zoom. Nathaniel, have you tried anything out yet, Nathaniel?
I just plugged numbers in and I got like the slope.
Into what exactly?
So I like did that thing where you were talking about like the y2 minus the y1 and all that stuff, and I just plugged like numbers into C and I got like the answer, but I just don't know how to like simplify that one form to find C. Because I know there's like another way to find C, but I just plug numbers in to find it.
Yeah, that's no good. This is not guess and check class, right? So that's never a good way to do it. So the general idea is this one here, right? And yes, I did finally invest in some technology. And that'll give you the average rate of change, which in this case is -1/4. So I've got to do, so what, f of what minus f of what? What's my inputs that I'm using?
C and minus and 1.
C and 1, I like it. So on the bottom, I'll just be C minus 1. And that equals, let me see if I can fit this in here, -1/4. Yay, can you guys still see that? Okay. So pretty cool with that. So if you weren't even sure what the first step was on number 42, it's all about average rate of change, and this is the average rate of change process. This is how you find it. And this is exactly what algebra is all about. I know the answer. I don't know a part that went into getting the answer. That's algebra. Throw a variable in, they just chose the letter C. So what is f of C?
1 over C.
Yes. So you get 1 over C minus, and what's f of 1, of course? Yeah, there equals
1.
No? Or actually, you're just saying -1. Okay. Over C minus 1. And now you can do something. What really, really, really sucks the most about this expression right here?
The fractions, or like the fraction.
Yeah, the
and like
fraction.
the denominator.
The fraction. fraction. Yeah. How do I kill this fraction on the top? How do I kill 1 over C?
Like
Multiply
cancel
by?
it out.
Multiply by?
C.
C. And whenever you do that at the top,
You do C.
all right, that's all I'm going to say. So distribute that. I'll give you this clue. Don't distribute the bottom. Because what do you want to do with a fraction? You normally want to see if it'll reduce. But you definitely distribute the top, and you should get something very nice. And that is all I will say. Anything else about, is that all right? First off, I don't want to leave you hanging too far, but that next step should be really nice.
So would that just be C minus C and then over C?
Oh,
and
wait.
then
What's C times 1 over C?
1
1.
or
Right? 1 minus,
okay, I get it.
okay, maybe. Because really quick, over here, somehow this is going to relate to this problem. If I had m, get in there, minus 7 over 7 minus m, can those cancel? Not
No.
necessarily, but if I took a negative out of the top, what does it become? If I take a negative out, the m becomes what?
Negative M.
Good. And the negative 7 becomes?
7.
And so those cancel. So the answer is negative 1.
Okay, thank you.
Because what's the difference between these two? One is multiplied by negative 1. So these reduce to be negative 1. That should help you with this problem. Okay. How about anybody else? Any questions? I'm going to clear this. All right, all this is going to go away. Say bye, everybody. Bye. There you go. You got a wave. I like it. Anything else, guys? That's so cool. It's like, oh my gosh, where's my fingers? All right. Okay, so let's get back into where we left off. Bum, 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 bum. So last time we finished section 3.4, composition of functions. So we're going to get into section 3.5.
I don't even think we went over 3.4.
Whoa, say again, sorry?
I don't think we went over 3.4. We did 3.3, and then yesterday we did the review.
Okay.
I have the same thing. I only have notes for 3.3.
Okay. All right.
Yeah, because we went over that test.
I know, but I know we talked about this. In fact, we did a problem with division in it, right? So we talked about f plus g. It just means add the two functions together, right? Wasn't that on that practice thing we did?
Yeah. We're the f divided by g.
Yeah.
Yeah.
All this section is, all section 3.4 is multiplying functions together, dividing. Yeah. And then they also have, what was the other piece of this? Barf, barf, barf. Barf, barf, barf. Let's see. No, I don't care. What was the other piece of this section? It was something, I can't remember. Well, just keep looking, Jeff, you'll find. No, I guess that's it. Yeah, that section really didn't have that much. Oh yeah, the other thing was this. Plugging one function into the other. So let's try out this one. I'm almost certain I didn't assign this one for homework. Maybe if I did. If I did, don't say anything. I'll do it. It'll be a freebie. So what do you think this part A means to do? Right here.
It means to put the output from G of 2 into F as the input.
Beautiful. Beautiful. Just like order operations gets us used to, you work from the inside out. So what is G of 2? What would I write inside here? What is, so I can do either I can just do G of 2 on its own. And of course, what do you get for G of 2?
1.
1. And then so F of G of 2 is also known as F of 1 because G of 2 is 1. It's just substitution. And so what's F of 1?
Three.
3. All right, just plug a good old 1 in there. Is that all right? So it's kind of like cover up the F, and you got to do G of 2. And once you get G of 2, oh, now you got to do F of that, F of whatever you just got. Okay, maybe. What about part, so that's part A. What about part B? I do the exact same thing, believe it or not, but what is G of X? What is G of
2x
X?
squared plus 1.
No, that's F of X.
5.
What's G of X?
Oh, 3z minus 5?
3x minus 5. I'm not sure where the z is coming from.
Oh, yeah, that's a z. I mean an x, my bad.
That's right. And then what does the f function do to anything you put into it? What's the f function do?
2 times the square, 2 times 3x minus 5 squared plus 1.
And then you can simplify that. Just FOIL that out, double it, add 1. Is that all right, guys? I mean, that's not that big of a step from just the basic idea of what function notation means. I'm just, instead of plugging a number or a single letter in, I could plug an entire other function, an entire expression in. I do exactly the same thing. I just replace x with whatever the hell's in there.
So
and then
what
simplify
is
it.
D or
Go ahead,
E
sorry.
asking? What is D or E asking?
Oh yeah, okay, so this evil notation here, I always hated this notation. I have no idea why they invented it. The other way to see this notation, the better way to see this, is the same thing. That is the same thing as saying G of X. The little O is like an of. G of X. But we already have the parenthesis that means of, right? So that's why I hate that this notation exists, to be completely honest. You might not be used to a math teacher being that honest with you, but there are parts of math that I really don't like. We could have made them much better. So I do for myself. Haha. And then I show you guys sometimes. Is that all right? So how would I do that? What is G of X?
3x minus 5.
And then what does G do to anything? It puts it there. It puts the function on its skin. And then, no, stop, Jeff. That's gross. Bonus points if you know where that's from.
Silence of the Lambs.
There you go. Very good. It's always a great reference, Jeff. Get everybody at ease. Yes, Clarice. All right, stop. Is that, you guys all right? I don't want to, I'm sorry that I'm joking too much. People always get upset at me. Are you guys with me on that idea? That's all that notation means, is just replace it with, they should really look at this. So what is another way this could be? I love the name of this. This could be written like this. So I love, it's like the fog. I'm like, all right, students relate to that. So I feel like I'm in a fog. But see, that these are just the same thing. They mean the same thing. And I kind of hate when we have multiple ways to write the same thing. It just seems like a waste most of the time. Is that cool? Is that all right? So these are the same as these. They're just written with this weird ass O. Oh man, somebody didn't like it. They left. Well, shit. Somebody wasn't liking it. So I mean, to finish this one up down there, you can just you just finish it up. You just whenever there's something you can actually simplify, you do. Please let me know if you have questions. It's okay if you do. Did that make sense, whoever asked that question? Or is that the person that left? You're right, man, this guy sucks at explaining things. Like, shit, that's my whole job. All right, nobody wants to talk to me. All right, fine. Moving on. I'm going to clear all this. It's all going to go away. All right, see, I told you. Okay, and we did this kind of problem. We did this kind of problem. I know we did. So we actually did talk about this section. I didn't necessarily bring the book up because there isn't that much in here. There really isn't that much in here. By the way, I'm going to be looking this way now because everybody's face is over here now. So that's when I'm looking at you, and that's when I'm looking at the thing. Okay. This one gets people. Let me let you guys read this instruction, see if you understand what it's asking you to do. Oh, shit. Do you see how this is the reverse of what we just did? So just a minute ago, they gave me F and G, and I plugged G into F, and I could see what it is. Now they're saying this is the result of somebody putting something into something else. This first one should be kind of relatively easy. Can you guys tell what the inside function is on the first one?
X plus 2.
Yes, I mean, right? If I said what's inside in the H function, you're going to say X plus 2. And if you don't, I'm going to think you're a little weird. I mean, X plus 2 is obviously inside. And what's the outside function? This is where things get a little bit more interesting.
X squared.
Yes, so if you plug this into F, which is exactly what it says to think about, what function was plugged into some other function to make these things here?
So then the x2 plus would have to be g of x because it's inside of f of x. That's how you figured out which one was g.
Yeah, the inside function must be g, and then you replace that with x to make the outside function. That's kind of the way you do it. Some of these get a little more interesting, and some of them have multiple possible answers. In fact, to be really honest, all of them have an infinite number of answers. But there's going to be one that is very obvious and maybe another one that's almost as obvious. Okay. Okay, okay. Let me ask a technical question real quick. Can you see a little image of a pen sometimes on the screen?
Yes.
Yeah.
Yep.
Thank you for the patience. This is a new thing for me, this little tablet deal, right? It's new, so I didn't know if only I could see that or if you could see it too, because I'm like hovering over stuff, and then I thought, maybe they don't see that pen. Like, what the hell is he talking about? Okay. So let me clear this out of here. So that's probably the weirdest this homework gets, is this backwards thinking. I love when the homework gives you a problem that's kind of backwards. This one, let me see if you guys get this one. Let me see if I can put this in a way that you can see what you need to. All right, let me see. No, I don't want to search, Jeff. No, no, go away. Do what I said, go away. Thank you. There, a little bit more. Okay, let me see. Okay, now, let me ask you a question. So we can't see the problem and the question at the same time, so I'm going to make up my own question. Do you guys understand what's happening here? So this is the graph of f. They've already plotted all the outputs. This is the graph of g. So if I ask you, what is f of g of 1? Don't say anything out loud. Just think about it for a few seconds here. So of course, what piece of that do you have to think of first? I just gave it away.
The G.
Right. Order operations told me that. I've known that forever. I always got to work on the inside. So what is G of 1?
3.
3. Does anyone not see where that came from? It's okay if you don't. You just got to, it's not okay if you don't and you don't say
I do not
anything.
see that at all.
Say, I'm sorry?
I don't see it. Help me.
Okay. So G of 1. So which graph am I going to look at, top or bottom?
The bottom.
Bottom one, because that's the G function. So what is
Okay,
G2? There, that's all. So instead of giving me the function, they give me all the answers to the function, which actually is better. Like, I got barely any work. I just got to go, oh, they must have gotten a 3, and maybe the G function is some horrendous thing. It does look like it's freaky as shit. I'm like, thank God they gave me the answers. I don't have to worry about the freaking work. And then what's f of 3?
2.
2.
It's
Done.
Yeah.
Go ahead. Sorry, Brian.
No, it looks like a little lower than 2. It's probably because I'm zoomed out.
Oh, yeah. Trust me. There might be some problems where they say estimate your answer. I think earlier we saw one like that for a domain and range problem where it wasn't exactly on the whole number. But yeah, this is a little bit of a issue, but I'm going to say it's close enough to 2 to just say it's 2. I like it. Okay. So I want you to see what's happening. I really enjoy, and most pre-calculus books do this. They give you the same problem, but they give it to you visually, they give it to you functionally, they give it to you graphically, they give it to you whatever. It's the same idea though, over and over and over again. All right. So either you learn it or you go insane, or a little bit of both. All right. You guys okay with that one? So there's all that stuff right there. Bam, 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 bam. How would you do this one? Let's see. G of 2.
Would it be 0?
Yeah, G of 2 is 0. Right? So
G of
you've only
0 is
done,
2.
and then G of 0 is 2. Holy shit. So let me write it down just so nobody freaks out. All right, let me see. So this very last problem, just in case you can't see it at the bottom, it says this. So I don't care that these are the same. I don't care. Stop caring. So G of, okay, what's G of 2? 0, right? So now to finish the problem out, what the hell's G of 0? Well, G of 0 is
2.
2. Done. Next. So the nice thing is, if I use the same function, I only have to look at the one graph. But I still do the inside first, and then I can do the outside, because I can't do G of this shit until I know what this shit is. That's the idea. Okay. Okay, maybe. Sure. And I think that should be, yeah, here's the same idea, except now they got F and G and H. They got 3 ones to do. Ooh, but it's the same idea. And here they give it to you in table form, same idea. So real quick, F of G of 8. What's G of 8? Can you see how to read this table? What's G of 8?
4.
0.
It's not 0. Here's the inputs, right? For G of 8, what's G of 8?
5.
Right there, right? 4. Become a thing. There we go. Isn't that G of 8? G of 8 is 4. Is that okay? And then it needs, and then what's f of 4? Now I know g of 8 is 4. Now what's f of 4?
Is 4? No.
4. Yeah,
Yeah.
4. Done. That's the f column and that's the g column. So now instead of looking at the f graph and the g graph, I'm going to look at the f column and the g column at the right time. It's the same problem. They just didn't plot the points. That's all. Do you guys see what I'm saying? They didn't plot the points yet. Okay, I don't care. I still got all the answers. I can just look at them still. I really want you to see it that way. Table is the same thing as the graph. It just hasn't been plotted yet. They're all the same information though. Okay. Maybe. Please don't let me, I don't want you to interpret my tone to mean that I don't expect any questions. I really want you to understand that not to overthink these problems. That's what I'm trying to get through to you. Is very often it's an overthinking. If you still don't understand a problem, please ask me, right? It's fine. Don't take it like, oh, it sounds like we should know. I'm not going to ask this guy. He's an asshole. No, come on. It's my whole thing. I love explaining stuff. But I don't hear anybody talking up, so I'm going to keep going. There's another table problem. All right. And then this is just like bonus questions down here. Okay. Let's see if I can use this thing. Look at me go. Oh, shit. I spoke too soon. I spoke too soon. All right. So since I don't hear any questions, I'm going to go on into the next section. Okay. So I want to talk about shifts. So can somebody help me out? Everybody do this for me. Every single person out there. Jet, can you please just humor me and make a little XY table and then graph this function. So I'll give you the inputs. This is trying to be a Y. All right, Jeff. My God. You got your little pen. You still can't write or shit. There. And then I want you to graph it. Let me see if I can play around with colors. All right. So what do you guys got? So of course, square root of 0 is
0.
It's crazy. Square root of 1 is
1.
holy shit. Square root of 4 is 2. Okay. Those are what I call the anchor points for a square root function. They are the main three. I always want at least 3 kind of points to know for every basic function shape. So here's 0, 0. Here's 1, 1. Here's 4, 2. And then you got your little fallen parabola. All right. Why did I do it over here? I got all this space over here, Jeff. I don't know. I don't know. So let me do this over here. Let me see. Let me make a different color. Green. So what if I had a function that did this? What is it going to do, Jeff? Let's do this. Yes. Actually, let's do this. Yes.
Are you done?
Yes.
Okay.
Good question. If I was doing this on the board, I would cover that +3 up with my thumb. Can you guys do that yourself? If you cover that +3 up with your thumb, isn't that the same function as f? Oh, somebody's chatting at me. Let me see. Can I do it with this? Jeff, just use your mouse, dude. All right. Oh, okay. Yes. Okay, good. Moves it. You're kind of ahead of me a little bit, but I love it, Josh. So it would take this, which is where? Where is that? It's right there. There it is. And it's going to increase every output by 3. Now, for some of you guys, I'm overstating it. It's like, why are you saying it all that? It just moves it up. Holy shit, Jeff. But I want you to really, if you're not as used to this, it takes this function, all the outputs that I used to get, all these outputs I used to get are now each going to be increased by 3. So for G, I'm going to have 3, 4, 5, right? Is that all right? And you can check it. If it's 0, n squared is 0, 0 plus 3 is 3. Blah, blah, blah. So every point just moves up 1, 2, 3. That point goes up 3. That point goes up 1, 2, 3, Jeff. And then that point goes up. You didn't give enough things, Jeff. 1, 2, 3. So now the graph looks like this. And this is a little weird to say, but aren't they sort of weirdly parallel? Like curvy parallel somehow. Are these ever going to hit each other?
No.
No, because they're the same graph. So they're always going to be sort of the same. They always have the same slope at every point. I don't know if that makes any sense. I'm overthinking this, right? I'm overanalyzing this. We don't need to know all that shit. Sorry. So now watch this. Is everybody cool with that? In fact, let me make this point right now. What if instead of the square root of x plus 3, what if I had like x squared plus 3? Wouldn't that just take a normal parabola and move it up 3? Same way, right? Every output that I normally would get from x squared would now be 3 bigger. How are you guys doing out there?
Good.
So if I have some function that is created by, okay, Jeff, you can't be doing that. Taking some other function and adding some, let me do this weird shit, you ready? Adding some constant to it. And the constant could be negative. What kind of shift will that be?
Down.
Well, okay, if it was negative, you're right, it would be down. But in general, this would be a vertical shift, up or down, depending on what k is. So k here is 3, right? All right. I like it. I'm going to erase this newest stuff here. You guys can copy that down if you want to. I'm not sure what you get from that. What's your eraser, Jeff? There we go. Okay, it's going to go away now. That is really satisfying. All right. So let's look at a different thing I could do here. Can I even use this thing? It's your first day, Jeff. Why can't I do that? All right, mouse, help me. There, that's why I couldn't do it. Okay. So what if I had, instead of this, and it's pretty cool, that's f of x there, right? Good old f of x we had over here. So what if instead of doing this plus 3 there, what if I do it here instead? This is going to be freaky.
Doesn't it move right?
Nope. And this is where it gets really, yes, it does, yes. But let's figure out why. What was the smallest, stay with me now, What was the smallest x could be here, of course? And we're dealing with real numbers. So what's the smallest x could be here?
A 0.
0?
0. What is the smallest it could be now?
-3.
3.
So every input, in order to have the same output, every input can be 3 less. Let me say that again. Because of this plus 3, all my inputs are allowed to be 3 less than they used to be. Does that make sense? That's why it does the opposite. You see this plus, and you think, okay, it must go in the positive direction. But no, x is going to react the opposite, because it's got to overcome this plus 3. X has got to go down 3 to make it normal again.
Is that because
Hold on,
it's in
need
a
that-
square root?
Say again, sorry. Say
Is
again.
that because it's in a square root?
It's because it's inside. Inside, period. So see how this shift is outside the main function. So that's going to affect the output. This one is in with the input. It's going to affect the input. It's going to move it left or right. So outside, up and down, inside, left and right.
No, I was saying like it's gonna do the opposite because it's in the square root.
That also.
Okay.
That also. Yes. So whenever it's with the letter, whenever it's with the letter like this, it's going to do the opposite of what it looks like. And the way I like to think of it is the X has to react. If I add 3 to it, they all have to be 3 less to make things back to balanced out. That's how I look at it. I don't know. Another way you can look at it is just, what's the smallest X can be now?
-3.
-3. Let me do this in black. So when I put a -3, so it's just going to move, every point is going to move 1, 2, 3 back. So this is going to be a shift, become a letter S, to the left 3. So it's going to take this point back 3. It's going to take that point 1, 2, 3. It's going to take that point 1, 2, 3. There we go. Get in there. Oh, shoot. Jeff, really, dude? It wasn't that big of a deal. All right, man. Bam. 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 Okay. Woo! So let's do this. Let's do this. So we don't have to suffer through my horrific, it's still bad. It's better, but it's still bad. I'm going to do everything we just did, but I'm going to do it in the graphing calculator so it's much crisper. Okay? So I'm going to close this. I'm going to stop sharing. You guys like, it's fine, man. I don't want you to share that. Okay. And then I'm going to share my calculator. Get up there, calculator. There we go. Can you see my calculator? Yes. Okay. Thank you. Can I do this? Oh, that kicks ass. I didn't even know the
Easier to
mouse.
see.
Sorry?
It's easier to see.
And
Yes, I
it's
know.
pretty.
So now watch. So it's all, if you have a graphing calculator, which you should, here's my square root of, and here's my all-purpose variable button. Square root of X. Oh, by the way, guys, can somebody remind me, maybe right now, shoot me an email. I just got the video of the calculator workshop. So I can download that and I can put it up on our Canvas or on YouTube even, I think. So you guys can go watch it. So they recorded all of it.
I got you. I'll
Damn
do
it.
it right now.
Okay, all right, it looks like a few people are, which is fine. I can always use at least one reminder. So if you're playing along with me, do me a favor. Here's a very important button. Zoom 6. See how it says standard? It'll take me back to -10, 10, -10, 10. So if I do zoom 6, everybody should look like this. Let me see, there's my pen. Yeah, I don't know which one I should use. All right, so pretty cool with that. So what's gonna really kick ass with this calculator is, what did I do next? I did square root of X. Now watch what I have to do. I have to hit the over arrow to come out of the square root, and then I can put my +3. And that's gonna be in red. So we already know what that should do. That should take that function and make it go up 3. There you go. Right? So if I can look at the table, see the table up here above graph? So if I hit second graph, I can see the tables. Look at that shit, that's awesome. 0 went up to 3, 1.4142 went up to 4.4142, blah, blah, blah. I just added 3 to all the outputs. Of course I did, because that's what the function says to do. And then if I do square root of X, plus 3. There's that one. That's cool. Is that the same colors I used? That would be so awesome if it was. I didn't do that on purpose. There we go. And notice this. Do you guys see how, does it look like that doesn't hit the axis right there? Do you see that?
Yeah.
And that's just a resolution issue. So here's something kind of cool. If I do zoom, my favorite zoom is zoom box. Because then what I can do, watch what I can do. If I move my cursor, I can hit enter, and that's a corner of a box that I can now open. And then it's going to zoom in. It's like enhance on CSI, right? Enhance. So now I got a little bit closer, right?
Never say that again. I will drop this class.
What's that? Oh,
That enhance
don't
from
get me wrong.
CSI.
But if I say this, will it be okay? The CSI enhanced shit is complete bullshit. It's like
Yes,
good
it is.
Lord.
That makes me very happy. Thank you, sir.
Okay, thank you. That's why I was kind of making fun of it, to be honest. Can you enhance that video? Well, sir, no. It's a resolution. What do you want me to do? Go back in time? Anyway, sorry. I'll stop. I understand your frustration. But if I keep zooming in further, and the reason is real quick, the graphing calculator to make graphs, it actually puts an input, gets an output, puts an input, gets an output. But how far apart are the inputs it uses? They're actually right here. This is the step size. This little triangle means step. It actually means difference, but the difference in the x's that it uses is 0.01. I could actually change that. I'm not going to get too deep in that. I just want to let you know that's why it'll have resolution issues when it's quickly going up or down. It's not going to be able to move left and right enough because it's taking kind of big steps on the x-axis. That's all I'll say. That's enough. Okay. So why don't we do a more interesting function? What about absolute values? Anyone know where the absolute value is in the graphing calculator? What looks like a really intriguing button that seems like, how could all of that be there? Anybody see a very interesting button that's like, holy shit, that's kind of a lot. Maybe like right there. Do you see the math button? I mean, my God. You got a math button. It's like, I'm going to hit that thing. What the hell's going to happen? All right. And one thing I want to show you, look. I don't know how much you guys know about this, but see this very first thing? It says arrow frac. So that makes something into a fraction. So if I did like 0.0856 and I do math to fraction, it changes it into a fraction, lowest terms. And I love it when I have somebody that took my 88 class and now they're taking my later class. I'm like, oh my God, why didn't I know about that? Anyway, sorry. But what's more important for us right now, if you go to y equals and then hit math and then go over to num, the very first thing is absolute value. So let's graph the absolute. Now your calculator might not be as nifty as mine. It might say ABS, parenthesis, then you just put an X there. It might not have the absolute value symbols. It's okay. You should be jealous, but you'll get over it. Please let me know if, I just hate the sea of boxes. I have no idea. I can't read faces. So let me know if, don't let me steamroll you with stuff. Now, what should I hit? Why does that look all freaky? What should I hit? What should I do to make it go back to normal?
Zoom 6.
Yeah, Zoom 6. I like it. Somebody's chatting. Is that what you said, chat person? Yes, thank you. So that looks better. And will Zoom 6 always show you the, but no, it's a good place to start. And then you might have to change the window like we were talking about. You might have to make WiMAX bigger or something. But start with Zoom standard. So what do you think is going to happen to this line if I do this, if I do absolute value of x plus, let's do minus this thing, x minus 4. What should happen? Now somebody's going to hit it and go, well, it did this. No, but predict. Can you predict what's going to happen?
Move it to the right.
Yes, exactly. When it's in with the variable, like somebody said earlier, which I love. I got to remember the cameras over there. When it's in with the variable, you move it the opposite of what it looks, because it's got to. So now, do you see how the very first thing that happens to my inputs is somebody takes 4 away from them. So don't all my inputs have to be 4 bigger than they used to be, which means they're all going to move to the right. I'm trying to do it from your perspective. Is that right? Yes. So if I do this, it should be shifted 4 units to the right on the x-axis. So let's see what happens. Oh, thank God. All right. I'm never sure when I'm going to go insane and forget all math. It just could happen in the middle of a class. And of course, if I did the absolute value of x with the -4 outside, it's just going to take that original and take it down 4, right? Because it's outside now, so it's going to affect the inputs. I'm sorry, it's going to affect the outputs because it's outside. By the way, I want to show you something. Let me see. I can do that here. Yes. What time we got? Okay. Where are you? Are you there still? Oh, that's good. Yeah, hold the pen backwards, Steph. That'll help. I want to show you this. As I'm writing, I'm trying to remember what it was I wanted to show you. Oh, yeah, I got it. So remember, so this guy, I love whoever said this earlier. You're awesome. But since it's inside with the variable, it moves it the opposite direction on that axis. So watch, what can I do with this -4? Can I get it with the y? Yeah, I just have to add 4, right? So now where's the shift? It's with the letter y, so it's going to move on the y-axis in the opposite of this. It's going to go down just like it did. You see what I'm saying? So if you, whatever letter it could be with, it's going to shift in the direction of that axis. So if it's inside the stuff, it's with the x, which means it's going to be a left and right shift. If it is outside the stuff, you can move it with the y, which means it's going to be an up or down shift. Okay, maybe, maybe, maybe. All right. So, let me stop doing that. I'm going to clear all that. Go away. What if I did this? Let me take this away. Go away. Go away. What if I do this? 4 times the absolute value of x. What should happen?
It's going to compress the function.
Yes, it's actually going to make the slope bigger on both sides, right? Like every output is going to be 4 times as big as it used to be. So it actually ends up making it skinnier. Like that. There it is. I was worried for a second. So there's the original, and there's the new one, because original output for -1 is 1, and now the output is 4. Is that all right? So what we got now is if I have a multiplier, it's going to either, I like that the word you just used, whoever that was, it's going to either compress it in that direction or it's going to stretch it in that direction. And why is it going to do that? Because it's going to be like an amplifier. I like to think, especially if it's outside, I like to think of it as an amplifier. So in this case, it amplified all the outputs by a factor of 4. So how would I make this blue line become fatter? What would I put in front of it?
1/2.
Sure. So if I put, let me just put 0.5 times the absolute value of x. There we go. I'm gonna fit. I like it. Of course it did, because it pushed down. It made all the outputs half as big as they used to be. So that essentially makes it wider. I love it. Okay. So what kind of, what other type of transformations could we have? There's one main type left.
A
Flip it upside
reflection.
down.
Yes, reflections. I love it. Let's go back to the square root of x. I like the square root of x. So what happens if I do this? Real quick, notice this. Do you see how, I think I pointed this out before, there's a negative button and a minus button. If you use them at the wrong time, now watch this, I'll purposely do this wrong. Negative, square, let's see what it does. There. If you get a go-to, right, not Goku, no Kamehame. If I get a go-to, do that because it's going to put the cursor on the problem. Oh shit, I meant negative. So what's going to happen when I push that? So is that going to affect the outputs or is that going to affect the inputs?
The output.
The outputs, because it's not inside with the x. So the square root of x used to go up above. Now it's going to, all the outputs are going to be the negative of what they used to be. So it should just flip around the x-axis. So let's see if it does that. Yay, Jeff hasn't gone insane yet. So how do I make it shift so it shows up over here? This is where things get a little bit freaky for people. If putting the negative outside, go ahead, sorry.
Oh, I was just going to say you put the negative on the inside with the x.
Yeah, and people freak out when they see this, but in this function here, what values of x can I not use?
Negative values.
Negative values. But now, this one, I have to use negative values, right?
Yeah.
If I try to put a positive number in for x, I'm going to get something that's complex, and I'm not dealing with complex stuff right now, thank God. You don't want to be. So that's going to make all my inputs have to be the opposite of what they used to be just to have the same output. I really want you to understand why it reflects or shifts the way it does. So sure enough, if I do this, the black line should be a reflection around the y-axis, and there you go. So how do I get it down here also? How do I kind of complete the little
negative
thing we got going? Sorry.
Negative on the outside, negative on the inside.
Yeah, negative on the outside and negative on the inside, and that'll be all the flips. It'll flip over the x and flip over the y, and it'll complete my little thing, and it's pink, and that's awesome.
Is there a way to get it to display both? Like put like a plus minus symbol before a radical in the calculator?
Let me think. I don't think so. I think you do have to put, there are some shortcuts with the bars. So let me show you this real quick. It could be, like if I wanted to do y2 quicker, I could actually say, let me get this right. Negative vars, y vars function. This is not really a good shortcut, is it? So it's negative of y1. But if y1, if the y1 is like this huge thing and you just want to flip it, that's what you could do. I don't know if that's at all related to what you're asking, but what you're asking, I don't think so. There's not really a plus or minus button. You have to put two separate because this can only handle real functions.
Okay, got it.
That'll get the same output. Shaboo! How are we doing out there? Isn't this nicer than watching me just try to crap? Sorry, you can agree. All right. Let me think. Yeah, so let me see. One last thing. What time we got? All right. So let me clear this, this, and this. Just to go back to the compression and all that kind of stuff. What if I do this? What do you think that's going to do? So you can memorize these, but I'm not the biggest fan of memorization unless it really is something basic. So think about this. All my X inputs, they're going to first be multiplied by 8. So what do I have to do to my inputs to make everything balance out? All my inputs have to be
1/8 of what
1/8 of what they used to be, right? So if I used to use 1 to get a 1 out, right? Square root of 1 is 1. Now how do I get a square root of 1? I have to put a 1/8 in. It's going to compress it on the x-axis. And remember what we said earlier. If it's in with the letter, it does the opposite of what it looks like it does. Right now it's 8 times x, but it doesn't become 8 times bigger. It becomes 8 times smaller, a factor of 8 compressed. So let's see what this weird shit looks like. There we go. If I could, let me show you more of the function. So let me go to window. I'm gonna make, I don't need x min to be there. Let me make x min -1, and let me make x max. Let's do, sure, 40. All right, so you can see what I'm trying to do. And let me make y max 8. Jeff, that's less, dude. You can do it. You can do it. 100. Too much, Jeff. If you would just stop and think, Jeff. All right, it's not too bad. So it pushed the function back. Let me make it a little bit better. All right. So it takes the blue line and it compresses it. And of course, if I'm going to compress it, what's going to happen to the function? It's got to go somewhere. So if you have a marshmallow and you compress it, where's it going to go? Up or down or both, right? So if I compress this thing, it goes, eh. No idea if you guys are with me or not.
Makes sense to me.
Okay. So it's just going to reach up higher quicker. Of course it will. Because what did I used to have to put into here to have the output be 8? What did I have to used to put in here to have the output be 8?
64.
64. Now what do I put in to make the output 8?
Just 8.
Just 8. So it makes all the stuff that used to happen way down the line, it makes it happen sooner because it pushes it in. Let's see if I can get this the right way. Yep. Okay, maybe.
Makes sense. What about applying like square roots to functions?
Oh, well, that's not really a transformation because it's altering what the function fundamentally is. But I see where you're going with that. That is something we're going to look at later. But you see what I mean?
Yeah.
I don't want to alter the basic shape of the function. I'm just moving it around. That's what this section is all about. If I apply a square root on top of a function that exists, it becomes a different function fundamentally, right? Okay. Sort of like if I take an absolute value of a function, it gets very interesting. Like, see, now you've gotten me. I want to do this real quick. What if I do the absolute value of, let's just do x squared minus 4. So what's x squared minus 4 look like? So it would take a parabola and move it down 4, right? Are you guys with me? So it would do this. This is going to be really neat. I can draw on my, yeah, here we go. Did I make it so you guys, yeah, okay. So here's the normal parabola, right? Normal parabola. And x squared minus 4 would make it move down 4. So now it's going to be down here. And then the square, the absolute value is going to make the part that's underneath here, it's going to make it flip. It's going to make it positive, right? So it should end up looking something like, shoop, shoop, shoop. Yeah, there you go. So let's see what it looks like. Let's see if Jeff, oh shit, I'm still stuck in pen mode. All right, let me clear that. Go, just, no, don't do that. Too much technology. All right. Am I still in pen? Oh, I see. There you go, buddy. I got, okay, screw it. Oh, man. So what should I hit? I should hit zoom 6. There we go. Look at that shit. Isn't that neat? Can you see that middle part is what used to have been down here, and the absolute value just forces all those positive. So that's related to what you're asking about. Applying another function on top of the given function, that's a neat. Of course, that's just what? That's just the composition stuff we were talking about before. Right, the outer function absolute value, the inner function x squared minus 4. I like it. All right, let me get out of here. I want to get back to the book to make sure if I didn't miss anything. Yeah. Okay, let's look at this guy. I like this. This is a question you know would come. It's like the backwards question. It says, here's a graph. Can you write a formula for it? There it is. I wanted to see exactly the way they said it. And I was like, where the hell's the instructions? Write a formula for this graph. Well, what is that fundamentally? That's the graph of what? What function?
Square root of x plus 2.
Don't go too far. Sorry, whoever's talking to me. So this is fundamentally, Jeff, dude, I have too many. How can you have too much technology? I do. I just do. All right. So this is, so let me put f. See how this is the graph of h. So I'm going to say the base function. This is what I like to call the base function. This is square root of x. Now this one's kind of neat because not only is it moved left and right, or is it moved up and down? And that is a trick question.
It's both.
Both. How much has it been moved left or right? It's been moved
Right once.
right once. So let me write that down. So one shift is right 1. And what's the other shift?
Up 2.
Yeah, up 2. I like it. Now, we need to figure out, how do I write h of x, which will be these shifts applied to this function. So how would I do the right 1? Where would I have to put 1, and what would it look like? I mean, what would it be 1? What would it be?
Square root of x minus 1.
Yes. Is that cool? When it's in with the x, it's going to move in the x-axis direction, which is left or right. Let me stop there for a minute. So this is like the next level of this. If you understand it well enough to do the problem backwards. Some of you guys look at me like, dude, I can't even do the problem forward. So, and what's missing here? What else? So that makes it go from here to here. And how do I get it to go up there?
Plus
Add
2.
2.
Yeah, just put a plus 2 out there. I like it. Can you put these together? Is that something you're allowed to do?
No.
So yeah, exact good intonation on that, Jason. In fact, the correct answer is hell no. Just like this does not equal that. Okay, let's stop that right now. Stop it. You can't have a square root distribute across a minus because square roots don't play well with subtraction. They're not based on each other. Is that cool? Okay. Maybe. So this is exactly what I was saying earlier. This is that kind of problem where they have an idea, you work with it one way, and then you have to work with it backwards. Let's see. Let's try another one of these. Oh, do they have another one of these? You assholes. Is that the only one you got? Dorks. All right, whatever. And then they get into the reflections. Ooh, look at that bad boy. So here is an exponential function, right? They got 2 to the t. That's an exponential function. And one thing I want you to realize, it doesn't matter what the function is. Whatever the function is, if I add something to it, it's going to make the function go up. So one of my favorite kind of problems is I'll give you a function. I won't even tell you what the function is. And then I'll say, all right, what would f of t plus 2 look like? So you just have to copy the shape, but make all the points go up 2. You don't even know what the hell the function is. It doesn't matter. So, oh, look at this bad boy. They got everything happening in this thing. What do you think is the last, how many shifts are there here? Let me start with that. How many shifts are there in this expression for this function?
My guess is 3.
That's a good guess. There are 3 shifts. Jeff, Jeff, I just forgot how to count. I mean, come on, that's not that big of a deal, right? I can still teach math, right? All right, so if there's 3 shifts, what are the shifts? What is this shift right here? It's not really a shift, it's a reflection, right? So I'm going to give that part away. Which variable is it on? Is it on the outside of it, or is it inside? Is it with the input or not? Is that negative sign with the input?
I would say
Yes.
yes.
Yes, because the input is t here, right? Is that cool? So that reflection right there, this one, I'm going to say that's the first reflection we're looking at. What is that going to do? How's it going to reflect it? Around the y-axis or around the x-axis?
The x-axis.
No. So it's going to take the domain, is going to make it the opposite of it. So it's going to reflect it around the y-axis. So it's going to be a reflection around the y-axis. Go ahead. What about this negative? That's going to take all the outputs for 2 to the t and make them flip around. It's going to take all the outputs and make them the negative of what they used to be. That's the one that's going to go around the x-axis. And I'm purposefully doing this in this order. The last thing you can do is this +1, because order operations says that's the last thing you would do. So the order of transformations, the order of reflections and shifts and all this kind of shit matters. The order matters. So I'm going to shift up 1. That's my last thing I'm going to do. Pretend like that's the word up. Oh my God. Is your imagination that good? I don't know. So how the shit am I going to do this? So let's identify a few points. So I got the point 0, 1, I've got the point 1, 2, and I've got the point -1, 1/2. Is that cool? Those are my anchor points for this. So let me do this let's try to do this in 2 steps. And this is so freaky for me because I cannot see faces except for Amber. So I don't know if this is getting through to anybody. Let me know. Just let me know. Is everybody cool with those? Those are what I call my anchor points. Remember, you have to have at least 3 of those bad boys. So I can take...
Using 2 and 4 for an anchor point.
Say again, sorry. Oh, there's another point. Sure, you can use 2, 4 too.
I was just wondering, because if you wanted to do like have a negative y, if that would matter, if that makes it easier, or if it's just a random point.
Oh, normally I like to kind of, all right, so depending on the function, there are kind of really good anchor points to use. And they actually are often -1, 0, 1, but not necessarily always. Like for a square root, I obviously can't have negatives. So I use 0, 1, and 4, right? 0, 0, 1, 1, 4, 4, 2. Because I can't go negative. But if I can go negative, I definitely want to use one of those just to kind of make sure I get both sides of the sucker in the end. Okay, maybe. So let me see. Can we do those first 2? Let's see if we can do those first 2. So like this point, let's do this point. This point, I'm going to reflect it. Let's do this in 3 steps. Let's be careful. The more comfortable you get, the less steps you can do with it. So let me choose a different color. Let's do blue for the first step. The thing is already blue. That's a good point. Let's do green for the first step. All right. Reflect around the y-axis. So this is going to stay right where it is. This is going to reflect there. This is going to reflect there. There. That, and how am I going to graph this with a dotted line because it's not the answer yet. It's just an intermediate step. This one stayed right where it was because it's right on the mirror. Let me stop for a minute. So I've only done 1 reflection. So the nice thing is, the less comfortable you are, the less you do at a time, right? So you either want to regraph it on different graphs or you want to get some freaking colored pencils, right? I love my anal retentive students. You're awesome with the colored pencils. So now let's apply the second one. It'll be red, blood red. So if I reflect around the x-axis, that point is now going to be here. That point is now going to be here. That point's now going to be here. And that point is now going to be here. And I'm maintaining this shape every time. So I just need some anchor points, at least 3. We got 4, even better. So it's still dotted because it's still not the right final answer. That's really good for me. Damn. That's like the best I've ever done in my life. Holy shit, I want to snapshot this. Don't do that. Don't. don't. All right. So I got one last one to do, and let's do it in, what color do I have left? Let's do it in fuchsia. Is that fuchsia? Is that what you call it? Or just pink? I don't know. I'm going to stop right now. Are you guys at all with me on what's happening up here? I mean, if you do it one piece at a time, it's not as bad. You okay, Doug? Sorry.
Yeah.
Okay. I just saw you unmute. So the last thing I got to do is just shift every point up 1. Up 1. Up 1. Up. Oh, look at that. That goes right. Look. Oh, I'm sorry. I missed you. Up 1. This goes up 1. Neato. And one last thing to be really careful about. I haven't had to worry about this yet, but where was the asymptote originally?
The y-axis?
No. X-axis, right? Isn't that the asymptote?
That's what I meant.
Oh, okay. So where does the asymptote move to now? Because what's the last thing I did? Everything goes up 1, including things like asymptotes. And now the asymptote is here. Oh my God, that kicks. I'm so happy I got this thing. So now it's going to look like this. Let's check it. Let's check it. Let's check it. How do I check it? Put it in the calculator, right? Crap. Has everybody got what they want from this crazy thing? I think I can take a snapshot. No? Not easy. Okay, whatever. I can just print screen. I don't know if that's going to work. We'll see. All right. Anybody need that still up there? Okay. So let's get the calculator. Let's see what it says. You guys are all, I can feel you saying, we've never stayed this long. Oh shit, I'm sharing the same damn thing. Jeff. Yeah, like we never stayed this long. What's happening? It's too bad. Let me clear this shit out. I don't need t's. I mean, t is just a dummy variable. So I think it was -2 to the -t, right? It was x, it doesn't matter. It's a dummy variable. And then it was +1, right? Okay. Let's see what this thing looks like. Oh, thank God. All right, it's the same. Is that the same thing we just got? I can't remember now. It's been too long. Okay.
Nailed it.
Yay! It's just blue, not pink, but I think we'll be all right. Okay, so before I let you out of here, let me see. I always talk longer than I meant to. It's just too bad for me. So I think the nice thing, I think I told you guys last time, 3.6 doesn't really have a lot of new stuff. It's talking about the absolute value function. We already talked about this right here. The fact that the absolute value is one of 2 things depending on what the input is. What they are going to do is they're going to focus on the shifts and all that kind of stuff, right? So what's the most important point on an absolute value? Same as a parabola. What's the most important point?
The vertex.
The vertex, 11. Right, so that vertex. So if I hide that, get up there. No. So to get the vertex to go here, I'd have to go over 3 which would be a -3 on the inside, right? And then up 4, which would be a +4 on the outside. Now, the part that isn't as obvious, it's a little mean, as it was double too, but do you see the -3 and the +4? And that tells me, so where's the vertex? At 3, 4. Hopefully that sounds very familiar to what you do with parabolas, right? If I have a parabola, you can do it, Jeff. You can do it. There you go. If I have a parabola that looks like this, x minus 1 squared minus 3, can somebody tell me where the vertex is?
-1, 3?
Yeah.
Nope, you got that backwards.
Oh, 1 positive 3.
1 negative 3. So when it's in with the x, it does the opposite. When it's outside, it does exactly what it says. So that kind of goes like this. The vertex is now at 3, 4. So 3 minus 3, 4. All right.
They're giving you the points in your equation, so you know what those points are, right? Is that what you're kind of going at?
Yeah, the fact that these show up here makes complete sense because I can see visually that's where the vertex is, exactly. And like I said, the 2 is a little bit evil, but I'm not going to expect you to necessarily see that. But at least where the vertex is, that turning point, that's the connection between the visual and the formula. You can see that right there. I like it. Just like, have you guys ever seen, what's this the equation of? Does anyone know what that's the equation of?
It looks like a hyperbola. I could be
Hyperbola
wrong.
would have a minus here.
Oh.
Is it a circle?
Circle.
Like an ellipse would have a different coefficient on one of the variable expressions. Because an ellipse has a different shape in the x versus y. A circle has the same coefficient. In this case, it's 1, 1, right? Because that's symmetric in the x and the y direction. The 1 and the -3, see why I say it like that? That tells you where the what is?
Center.
Center. I like it. So normally the center is at 0, 0. Let me put an open circle there. When I have x squared plus y squared equals 9. This has shifted that center over 1. And this is going to be where now? Did I say that right when I said that earlier? I probably didn't. And I'm trying to make a big point here. See how they're both in with the letter? So where would the center be? You got to be careful. It'll be at 1. When it's in with the letter, it does the
opposite, -3.
Opposite. So it'll be 1, -3. So the center would be now at 1, -3, and it should be an open circle because it's not a part of the circle, right? How much of a radius does this sucker have? Does anyone remember? Good old Pythagorean theorem. So 9 is radius squared. So of course the radius is
3.
3. I like it. So you could just go up 3, over 3, down 3, back 3, and then make your circle. So drawing circles is nice. You find the center, and then you go the radius, 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 radius. Connect. Done. I like it. Okay, I think that's enough. I've really thrown a lot at you today. So, and I got to play around with you're the first class that got to see my little pen thing with jig in action. All right, so if you have any questions, stick around. Otherwise, I will see you next week. And don't forget, I did mention about the extra office hours thing, right? You guys remember that?
Yeah. You'd mentioned that at the end of class yesterday.
You go into Canvas, there's a module called Extra Office Hours, and inside that module is a link. So it's Tuesdays and Thursdays. I can't remember the times off the top of my head, but it's in there. So if you want to, it's nothing necessary, but if you want to, you got some more time if you want to come there for homework help. All right, so anybody need help right now? You guys have any questions about something? You're welcome, Zach. You're welcome.
Later, fam.
Dude, all right. Easy, bro. Nice weekend. Thank you. Okay, I'm out of here too. Bye.